So we have discussed projectile on a plane surface. Now in this video I am going to discuss about projectile on a inclined plane. Let us discuss projectile on a inclined plane and we'll see the properties of those projectile on inclined plane. So first of all, let me draw inclined plane. Suppose this is inclined plane and the angle of this inclined plane is say theta. Alright. And suppose we start a projectile. You project a body from here and the body goes like this. Suppose so we are projecting this say, let's call it, suppose this is the velocity, this is the velocity, this is velocity, say call it V naught, and suppose the angle it makes with this inclined plane is say alpha. Alpha is the angle. So in order to analyze this, see, we will be interested in finding out this maximum height from the inclined plane, right? With respect to surface of the inclined plane, what is the maximum distance this, and what is the range of this, what's the time of flight, all those things that we have found in case of plane surface, we will do it for inclined plane also. We will do it for inclined plane also. Alright. So the very first thing I would like to do is, let's take a coordinate system. See, I always tell you to take a coordinate system. Once you take a coordinate system, your work becomes very easy. If this is the x-axis, I have taken x-axis along the incline, and y-axis, of course you have choice only in one of the axes. Y-axis has to be perpendicular, right? So this is the coordinate system. This is the coordinate system. And suppose this is body while moving along a projectile motion. So on this body, what are the forces acting? The only force which is acting is mg. The only force which is acting is mg. But now mg can be resolved in this coordinate system. So this is your x-axis. This is your x-axis parallel to this axis. This is your y-axis. And what will this angle? This line is same as this line. This line is perpendicular to inclined plane. This line is x-axis, so it is parallel to inclined plane. And this is y-axis, so it is perpendicular to inclined plane. So this is the same as this. And this is mg. You can shift the vector. So whatever angle you have over here, same as the angle over here. So this angle is theta. You can do it very easily. So this is also theta. Okay. So this force can be split into, I can split this force as mg sine theta minus I cap, mg sine theta minus I cap, you have the component in negative x direction, plus mg cos theta minus j cap. See, mg cos theta is also along negative y axis, mg sin theta is also along negative x axis. So unit vector along negative x is minus I cap and unit vector along negative y is minus j cap. So this is the force we will split like this, and this will be equal to mass into acceleration, and acceleration is what? Ax I cap and ay j cap. So if you create the coefficient, this m will cancel out. So your ax comes out to be minus g sin theta and ay is minus g cos theta. When it was plane surface, this theta was 0. For a plane surface, I can say this inclined plane, when theta goes to 0, will go to a plane surface. When it is a plane surface, ay is minus g and ax is 0, because theta goes to 0, sin theta goes to 0 and cos theta goes to 1. So ax becomes 0 and ay is minus g. That was what we had in case of plane surface. And this will be equal to dvx by dt, so equal to dvy by dt, because you know v is Vx I gap, Vy j gap, and acceleration, which is dv by dt, is dvx by dt I cap and dv by dt j cap. Alright, so from here we get Vx equals to integral of g sin theta dt plus c1, and Vy is plus c2. So this will give you what? Minus g sin theta t plus c1 minus g cos theta t plus c2, and you know Vx at t equal to 0 is, or say the value of Vx at t equal to 0, value of Vx at t equal to 0 is V naught cos alpha, and value of Vy at t equal to 0 is V naught sin alpha. So this implies if I put here t equal to 0 and Vx equal to V naught cos alpha, I get C1 equals to V naught cos alpha, and here I put t equal to 0 and Vy as V naught sin alpha, then this is C2 is V naught sin alpha. Alright, so your Vx as a function of time is V naught cos alpha minus g sin theta t, and Vy is V naught sin alpha, and what is this? G cos theta t. Alright, so till you have this Vx and Vy, the body is going to gain or lose, when this Vy is positive, then Y of the body is increasing. When Vy becomes negative, Y of this body is going to fall. Means this Y is what? Y is the distance from this inclined plane. Y, x coordinate and y coordinate. X coordinate is telling you distance of this body from y axis, and y coordinate is telling you distance of this body from the inclined plane, which is x axis. Which is x axis. This is your y, and this is your x coordinate, right? This is y and this is your x coordinate. So we would be interested in finding out what's the time instant at which this y goes to maximum. See, y will keep on increasing till it is more than 0. But you see, v naught at t equal to 0, this is 0, this is v naught sin alpha. As the time passes on, this factor keep on increasing, and this factor remains constant, right? So this factor keeps on increasing. So a time will come when this will become equal to this, and at that point Vy will turn to 0, and then at that point body won't be gaining any height, and that will be the maximum y, you can say, not maximum height. Maximum height is of course this. So maximum y max, you can say y max. Y max happens when Vy is 0. And from the calculus also you know that y is maximum when its first derivative is 0, or y become maximum when Vy is 0, and that implies what? From here, V naught sin alpha minus g cos theta t is 0, or you can say t is upon g cos theta. So that's the time of ascent, you can say, for this coordinate system. This is time of ascent, and thereafter y will start falling, and this time of ascent will be equal to time of descent. We have proved it in last case, so you can do it yourself. The time of ascent, the time taken by the body to go to y max, and then going from y max to y equal to 0, that is time of descent. Time of ascent will be equal to time of ascent, means going from this point to y max, maximum y, and then time of descent is going from y maximum to y equal to 0, again coming on the inclined plane, will be equal to time of descent and that will be equal to T, which is equal to V naught sine alpha G cos theta. Alright, so time of flight is how much? Just make a note of it. Time of ascent plus time of descent, that is 2T 2V naught sine alpha upon G cos theta. Fine? Okay, fine. Now, and we can calculate Y max also. See, we got Vy, right? We got Vy. So this is Vx is what? Dx by dt, and this is dy by dt. So I will take dt on this side and integrate it. You have this is dx by dt equals to V naught cos alpha G sin theta t, and that will give you dx equals to V naught cos alpha minus G sin theta t dt plus some constant, call it C1 dash. So that will imply what? X equals to V cos alpha t C1 dash. And you know, at t equal to 0, both x and y are 0. So x is 0 at t equal to 0. That implies if I put t equal to 0, x has to be 0. That will happen only when C1 dash is 0. Similarly, your dvy by dt is V naught sin alpha minus G cos theta t. That is dvy integral is going to be V naught sin alpha minus G cos theta t. Sorry. C2 dash, and we have y equals to V naught sin alpha t, and this is G cos theta C2 dash, and at t equal to 0 y is also 0, so that will happen only when C2 dash is 0. So you got xt and yt. Xt is V naught cos alpha t minus 1 by 2 G sin theta t square, whereas y coordinate at time t is V naught sin alpha t minus 1 by 2 G cos theta into t square. So time of ascent is this. So if I put this over here, then I get y max. Y max would be, this is a time interval till which the body gains y keep on increasing till this time. So y max is going to be V naught, just put this y over here at the place of t. So V naught sin alpha upon G cos theta, and t square is V naught square sin square alpha. So that will give you what? That will give you V naught square sin square alpha G cos theta minus V naught square sin square alpha upon 2G cos theta. So that will finally give you y max. That is going to be V naught square sin square alpha upon 2G cos theta. Now see, whatever formula we are getting for inclined plane, you will see that the formula that we have got for plane surface will appear to be a special case of this. See, I told you this inclined plane will tend to a plane surface when theta tends to 0. So this formula for inclined plane, y max for inclined plane, will become a formula for the plane surface when I make theta equal to 0. So when theta is 0, cos theta is 1, and then your formula becomes v0 square sin square alpha by 2g, which is the formula of Ymax for a projectile on a plane surface. Get your point? If I put theta equals to 0, then I get Ymax equals to v0 square sin square alpha by 2g, which is nothing but the formula for the maximum height in case of plane surface. So every formula that you are finding over here will be a kind of generalized formula, and that will reduce to the formula for a plane surface when you make theta equal to 0. Right? So this is Ymax, and if I am interested in this is Ymax, this is this one. Ymax. At this point, the velocity will be Vy component will be 0. It will be only Vx. So velocity will be this is only V, which is nothing but Vx. There is no Vy. So velocity will become parallel to inclined plane at this point. At this point of time, velocity will become parallel to inclined plane, and this Ymax is, we have calculated it. Right. Now we are also interested in finding out what's the range. So range is what? The distance traveled, the value of x. When I put this is the distance traveled along the inclined plane during the whole projectile motion. So projectile motion takes place for this amount of time. So the value of x after this time is going to be range. The x value, the horizontal distance traveled during this interval of time, that's going to be the value of r. So r will be what? Just put this t equals to time of flight, 2v0 sin theta by g cos theta. So this will be v0 cos alpha, and t is 2v0 sin alpha by g cos theta, and 1 by 2 g cos theta, and t square will be what? 4v0 square sin square alpha upon g square cos square theta. So this will cancel out. This will be g cos theta. This 2 will cancel out. And what do we have now? Yeah. So we have 2v0 square. 2v0 square. Sin alpha can also be taken common. I committed one mistake over here. This is g sin theta, sorry. That's why I was getting the incorrect answer. This is g sin theta, and this is going to be g square cos square theta. Yeah, now it is correct. Yes, g sin theta. So that comes out as 2v0 square, 2v0 square sin alpha cos alpha upon g cos theta minus this g will cancel out. So what will remain is what? 2v0 square sin theta by cos square theta is what? Let me take this cos square theta and sin theta like this only, or you can write tan theta sec theta. Better you can write tan theta sec theta, and this is sin square alpha. Get it right? So this will also reduce to the formula of range for linear projectile on a plane surface. If I put theta equal to 0, if I put theta equal to 0, this sin theta will vanish, so whole term will vanish. Cos theta will be 1, this is cos theta will be 1, and you will be having 2v0 square sin alpha cos alpha by g, that is v0 square sin 2 alpha by g. So this formula will reduce to v0 square for theta equal to 0. That is the range for a projectile and inclined plane. So I think we got all the parameters which are used to describe projectile on an inclined plane. We almost got all the parameters which are used to describe this projectile motion. We got the time of flight, we got the range, we got the maximum y, all those things. I can't say maximum height because after this also height is more. This height can be more than this height. Height means usually people consider it from the horizontal plane. So we don't say height, maximum height. I'll say maximum y. Or if I take this as a reference for measuring height, then I can say maximum height also. If I take this inclined plane as the reference for measuring height, then I can say h max also. This can be called h max also. Alright. So I think this is enough. We discussed almost everything in this topic. Okay, so we'll do some numericals on this. Okay, thank you very much.